Hello everyone, and we continue building BudgetClick-2026 personal finance and wealth management application. The goal is zero cost, serverless, no server. The only backend thing we will need will be S3, AWS S3 for the storage, for synchronization of the data between clients. So this will be the application, multi-client application. You will be able to track your finance on desktop, on all your devices, iOS, mobile phones, Android, etc. Now let's continue. This is the next episode, and we focus on documentation. First of all, let's go through the plan. We need to finalize the documentation. Here is the documentation, and the plan will be the following. So we need to finish the manifest, synchronization, data schema, storage format, chunk format, encryption, migration, client setup, and the last but one of the most important and critical things is we will need to check iOS PWA feasibility, and that will the outcome of this experiment will show us whether we can continue with this solution as iOS PWS, which is completely free, or we will need to explore some other possibilities. Right. So between the episodes I added one little tool or utility which helps me concatenating the files in this workspace, and I also added a task, VS Code task, for running this concatenation. So run task and concat files. How does it work? We select several files. We copy the path of the files. Control K, Control Shift C, combination of these keys, and then we just run this command, concat files, and the contents of the files is here in this file content file. I also added git ignore. This file ignores helps Git ignore the files which are listed here, and in our case this is files content txt, so this file which doesn't need to go into the repository. This file also doesn't need to go to the repository, so let me add this file to git ignore, tmpmd. Okay, and then we can commit the changes. This one is in process, and the commit message is add concat file utility. Good. This one added. Let's sync. I have also updated design spec a little bit. Let's see what I changed. So I cleaned up a little bit the documentation. I removed. I also changed the structure of the chunks, the structure of the files on the storage. So I removed account plus month synchronization, and instead we keep all the account transaction, all the accounts and all the transactions per account in one monthly chunk, and that name will be obfuscated as something something which is not clear, because here in this case we understand that this is the 2026 January, and in this case it's not clear what it is, and the data will be mapped, the file names will be mapped in the manifest. We'll cover this just a little bit later. Before synchronization, manifest temporary must be created. Yeah, this is a little note to the synchronization. We'll also cover it a little bit later. Yeah, so that's basically it. So all the changes, those are all the changes which I made to design Markdown. Let's commit it, update design Markdown. We also added last time. We also added these little files, but this is not really a great approach. I think that we will refactor the files a little bit. What we will do is we will break this file into smaller files. Let's collapse all the headings. So what do we have? Architecture, technology stack, infrastructure, security model, identity, storage, layout. So here we have a storage contract. The storage contract will be changed, so we don't need all this information here. So all we need is storage layout. This stays. Okay, purpose, remove, design principles. Okay, let's keep it. Storage layout, let's change it a little bit. Reference, chunks, no, the chunks will stay flat. Statistics, attachments, good. Attachments will be sharded. Obfuscated as mapped in manifest. Same, also obfuscated. Chunks will also be obfuscated as chunk. Mapped in manifest. Reference, accounts, categories, manifest, obfuscated. As accounts, something like that. Obfuscated as okay, let's just keep it without prefix. Also, contractors will also be obfuscated. Something like that. Sharded. Attachments will be sharded. Obfuscated. Oops, sorry. Also mapped in manifest. Sharded. Let's change this space. Tabs will be 2. Okay, attachment sharded, and attachment name obfuscated, mapped in that's actually a good question. Maybe we will keep the attachments attachment map Also obfuscated, mapped in manifest. Mapped in attachments map. Question mark. All objects are encrypted before upload. Object name where practical. Obfuscated where practical. Whether monthly chunk name predictable. Okay. To do. Think about attachment mapping. Maybe mapping in record will be enough. We also need. Do we also need to keep the attachment meta? For example, original, file name, etc. Probably not. Probably storing the file name for the obfuscated file name for MVP is enough. I think so. Yes. Okay. Storage object life cycle. Every storage object follows the same life cycle. Object serialize, encrypt, upload, download, decrypt, deserialize. Okay, no problem. Storage objects manifest. Storage objects manifest. Okay, let's keep it. Owner, update frequency. No, we don't need this. Manifest. Okay, does not contain. Okay. Reference objects, counts, contractors, owner, update frequency, nodes, from monthly chunks to reduce synchronization work. Okay. Monthly chunk. Monthly chunks are the primary synchronization unit. Synchronization scope account plus months. No. Each chunk contains the complete state for all accounts during 1 month. Owner, update frequency. Okay, chunk metadata. Each chunk contains metadata describing itself. Metadata includes schema version, chunk version, account ID, months, created at, updated at. Okay, chunk metadata is stored inside the chunk rather than in the manifest. Okay, good. Contains metadata transaction records, does not contain attachments. Statistics. Good. Contain pre-computed aggregated data. Purpose: faster application startup, reduce client computation, historical summary. Statistics are derived from transaction data. The calculation strategy is specified separately. Good. Owner, don't need this. Attachments store binary files. Example: receipts, invoice, photos. Attachments are independent storage objects. Attachments metadata is defined separately. Object versioning. Every storage object is independently versioned. Versioning supports synchronization backward compatibility. Version numbering is defined by the migration. Okay, let's keep it for now. Object independence. Storage objects should remain as independent as possible. Changing one object should not require rewriting unrelated objects. Yeah, that's true. Changing a category should not regenerate monthly chunks. Okay. Changing a monthly chunk should not modify reference objects. Okay. Object ownership. Every storage object has exactly one owning subsystem. We don't need this. Naming strategy. Object names are considered implementation details. Goals: avoid exposing meaningful information, support future storage migration, remain compatible with S3 compatible storage. The final name in storage will be defined together with synchronization protocol. Object envelope: every persisted object shares a common storage envelope. The envelope is responsible for object identification, version information, encryption metadata, payload. The envelope format is defined in Encryption Markdown. Okay, maybe cover that later. Migration: storage migration operate only in storage objects. Storage migration is independent from local database migration. Migration rules are defined in migration. Okay, keep it like this. Storage migration operate only in storage objects. Storage migrations operate only on storage. Okay, future compatibility. The storage format should support future additions without requiring redesign. Expected future object types include assets, investment data, banking integration, shared storage, snapshots, backups. New functionality should introduce new storage objects whenever possible rather than extending existing ones. That's true. Related documents. Okay. Okay, remove this one. Good. Storage contract. Let's commit this. Okay, so now it's shorter, about 100 lines less. Good. Commit, update, storage contract. Good. Okay, so we have defined manifest in storage contract. All right, good. The next, what do we have next? Manifest. Okay, let's define the manifest. Then let's also check if we have anything with regards to the storage here in design markdown. Storage layout. Okay, the storage layout, let's remove it from here and add it to the storage contract. And let's also check if we really need storage. Okay, so we have the storage layout here and we also have storage layout here. Let's compare these two documents. Let's see what the documents say here. Storage layout here, that's storage contract. Okay, bucket, manifest, reference, chunks, statistics, attachments. Good. So we can safely remove this from design markdown. Next, manifest. Let's go down into manifest and let's actually design manifest right now. Okay, for that we will start a new chat here. Let's design. Well, let's first of all manifest. Type. Structure of the work directory will be docs. clients, or maybe just client, because we'll have only one client. Then the client will have source and types. We will also have the storage. And manifest will be here. Manifest TypeScript. We will also need package JSON and tsconfig JSON. Okay, here is the design specs, and next we will copy both files, this and this, and let's see. Okay, I concatenate files, file content, design MD, good. Control C and Control. Let's see if there will be enough. Yeah, there's enough space. Okay, let's see what ChatGPT suggests. Okay, well, first of all, good. Use type, not interface. We also have some code style conventions. Well, as we started to code, to sketch out the code, okay, we will have some coding style conventions and AI assisted development conventions, and for that let's open the constitution. So I have it in my repository on my GitHub. The constitution will be this one. We will use compressed constitution. Okay, copy and okay. So constitution. Let ChatGPT know. Good. So what do we have here? Manifest schema version. Manifest version created at, updated by, references, manifest references, chunks, statistics, attachments. Good. Schema version, manifest version. Manifest object is what is a manifest object? Manifest object. Object key version. Manifest reference accounts, categories, contractors. Again, manifest object. Object key version. Good. Manifest attachments, map. Manifest object, object key version, root. Okay, very good. Manifest entry, object key version. Then everything reads more references, export type, manifest references. How do we map chunk month with the obfuscated file name? Chunks. Okay, so chunks will be mapped or identified by the string, and the string will be this date or the months. Good. Right. Provide complete code for manifest TS. Good, let's copy this and save here. So we will have new folder, client types, and in this folder we'll create manifest type. Good. So this will be the type. Let's also change settings, preferences, tab size will be 2. Let's add annotation. Good. Okay, we have finished manifest type. Let's first of all update settings. VS Code settings. Cleanup, commit, cleanup, design, MD. Add manifest type. Let's close some tabs. Okay, so next, so this is done. Let's go down into synchronization. Synchronization. Start next project. BudgetClick. Let's start another chat. Let's design synchronization process. We have multiple clients and encrypted storage. When the client or a client starts, it loads only the actual data plus data plus 50 records, infinite scroll, update triggers sync storage sync. Good. Design specs. Good. Design specs. Let's copy. Okay, first we can use manifest type already, sync and design. Control Shift C, run task concat files, and here we have the files, all the files, and copy and paste to ChatGPT. I think the current, okay, so is missing one important piece. The manifest cannot be synchronization. Okay, why? In our design spec, the manifest is a synchronization lock actually. So first of all, before the synchronization, we first create the temporary manifest file which shows that the synchronization is in process. When the synchronization is complete, that manifest is unlocked and the new manifest is written or rewritten, overwritten. Okay, with S3 compatible storage there is no transaction. Two clients can both download manifest v10, upload different chunks, upload manifest v1. The last manifest wins. I would redesign the sync around compare and swap on the manifest, making the manifest the only object that requires optimistic concurrency. Okay, let's see what it suggests. Synchronization model, 3 object types to synchronize manifest chunk reference object. Chunks are immutable with respect to their object key. Whenever a chunk changes, new encrypted object, new version, new object key. Example, chunks, manifest maps. This removes races during uploads. Okay, we will talk to ChatGPT a bit later. Let's look through the next sections of its suggestions. Startup, synchronization state, upload algorithm. Okay, let's summarize your suggestion. Be very brief. Use immutable chunk objects. Never overwrite. Upload a new object and update the manifest reference. Make the manifest the only compare and swap object using manifest version. Track local sync state with base version. Can we lock sync while another client is syncing? Can we collect garbage after sync failure? Can manifest lock or temp be the lock? For example, manifest current manifest version 10, manifest lock version 11. The other client sees that manifest lock exists and does not sync until the sync is over. The other synchronization process is over. What do you think about this? Can we lock sync while another client is syncing? Technically yes, but not reliably with only S3. The problem is that S3 doesn't provide distributed locks. Okay, if a client crashes after acquiring the lock, every other client sees the lock forever unless they implement expiration and recovery. You'd need things like lock owner, time step, expiration. Lock stealing after timeout, yes. Can we collect garbage after sync failure? Yes, in fact, immutable objects make that easy. Since only objects referenced by the manifest are considered live, so it suggests the immutable objects and swapping after synchronization. that makes sense. That actually makes sense. So then you suggest compare and swap strategy. First, upload updated files. 2, update manifest locally with the new files. 3, upload manifest, new manifest. 4, remove old files. Is this right? Yes, with one important change: upload new objects, download latest manifest, or ensure it's still the one you based your work on. Create a new manifest locally pointing to the new object keys and increment manifest version. Compare and swap, upload the manifest. Alright, let's ask the following questions. What if manifest has changed remotely? Concurrent syncs, failed sync. Okay, so it says that if the manifest changed remotely, we just resolve the conflicts. In our case, we merge the changes. Simple strategy. Concurrent synchronizations. Alright, so concurrent synchronization actually boils down to the same strategy when the manifest changed remotely by another client, for example, which means that the second concurrent synchronization will simply fail because it will find a new version of the manifest. So it will just go back to this and merge the changes first, and then make another attempt to synchronize. Okay, what about failed synchronization? In this case, the new chunks will be simply orphaned. The manifest will be never updated because manifest upload is the last step in the synchronization. Okay, and then the garbage collection will remove orphaned objects which are not referenced by the current manifest. Okay, and what if garbage collection is run during the sync of another client? It will collect new chunks, so the manifest containing them will be broken. Okay, so it says that that really is the challenge with immutable objects. So the garbage collection can actually remove chunks which are in progress. And the solution is there are several solutions. One, grace period, which is recommended. So we will collect garbage which is older than a threshold, for example 24 hours maybe. The second strategy is reference counting, mark and swap, much more complex and requires tracking historical manifest. Yeah, that's complex. Version retention, keep the last n versions of each chunk before deleting older ones. Okay, so grace period is still unreliable because the sync can retry after that grace period. Okay, so ChatGPT agrees. It says that a grace period is not a solution, so that's not a correctness guarantee, because client A uploads new chunks and that then goes offline for 3 days, for example, and the garbage collector on another client deletes those chunks and manifest becomes orphaned. Maybe yes, maybe not. Yeah, and commits the manifest because A comes back and successfully commits the manifest, but the chunks are already gone, and it will break the application completely and forever. So that's not a solution. So instead, it suggests to return back to stable object keys, the solution which we originally suggested. Okay, so then let's keep it simplest possible. Stable object keys, no garbage collector. What about so synchronization lock is not needed. What is your solution? Okay, so this is what it suggests. It would go with a Git-like optimistic synchronization, but with stable object keys, object layout, okay, same as before. The manifest no longer maps months to object keys, only to metadata. Manifest entry version, okay, or version checksum. Local state, each local object stores. Sync date, dirty. Base version is the remote version. The local copy was based on synchronization for each dirty object. Download latest manifest, compare version, save to upload. Okay, let's suggest the following. Can we do the following? Before each chunk, synchronization, download manifest, compare the chunk version, newer, merge, if newer, merge, retry, upload new manifest, repeat for each chunk. Can we also have a sync status file, say per each file or manifest section per each client? Okay, so ChatGPT likes my solution. Good. It says that actually prefer per object synchronization over a big commit. Good. Per client sync status, I would avoid. Okay, so it says that it's maybe not a good option. Okay, so let's keep it simple for now. Per object synchronization. update the sync markdown spec. Let's get this sync spec. Let's clean it up first. We don't need this. Synchronization unit, remove this. Remove this. Local workflow, we keep it. Synchronization flow, we keep it. Dirty objects, keep it. Manifest, let's keep it. Object version, every storage contains a version. Okay, let's keep it. Optimistic concurrency, keep it. Merge strategy, keep it. Conflict detection, keep it. Conflict resolution, deleted entries. Deleted entries remain as tombstones. Okay, that's good. Reference data is synchronized independently from monthly chunks. Attachments, statistics, synchronization triggers, client identifier, error handling, feature improvement. Okay, related documents removed. All that. All documents here are related. And we also remove synchronization from synchronization model from the design spec. Sync flow remove. Recurrency account. Okay, good. Manifest sync, Ctrl K, Ctrl Shift C, concat files. Okay, and manifest if necessary. Let's go. Good. Manifest has not changed. Now let's see how to change the documentation. Provide sync MD code. Copy and paste and see how it changed. Let's have a look. Okay, we don't need this. And in the end, we also don't need this. Cool. Design principles, synchronization unit workflow for each dirty object. Good. Compare object version, download remote objects. If needed, merge upload objects, update manifest, next dirty object. Good. What else? Synchronization engine downloads the manifest object locations, object keys. Every manifest stores the latest synchronized version for every object. Good. Before synchronizing a dirty object, download the latest manifest, compare the remote object version with the local base version. If the version matched, upload the local object. If the remote version is newer, download the remote object and merge. If another client updates the manifest before it can be uploaded, synchronization of the current object is repeated using the latest manifest. Objects are synchronized independently. A conflict affecting one object does not prevent synchronization of other objects. Good. Okay, everything else remains unchanged. Good. Okay, let's see if we need to update. Do we need to update anything in design markdown? All sync issues must be in sync markdown. final check. Okay, good. Keep it like it is now. Update sync markdown. Push. All right, we have completed synchronization design. Let's close all the tabs that we don't need. The next step is data schema. Okay, identity schema, entity schemas, record lifecycle schema versioning. Okay, so we will add a new types. We will need to add the types for records, for all the reference data, for statistics maybe, maybe not this time, but record, we will need records for sure. Okay, for that let's start a new chat project. Let's start a new chat. Let's define the data schema for records and reference data, reference, records, accounts, and reference, and all other reference data. Current design specs. Okay, design schema, purpose, remove, schema versioning, blah blah blah, common fields, record, nodes, direction, account, category, contractor, recurrence, attachment, relationship, identifier, strategy, life cycle, future compatibility, open decisions. Okay, we will remove design, remove schema from the spec and use use client types type name instead. Update design data schema, data schema MD, provide types code. Good. Current design specs, schema design manifest, storage contract. Okay, we don't need it. Concat related documents, we don't need this. Future compatibility, okay, let's keep it for now. Data schema design manifest, concat these files, copy these files, and let's see what ChatGPT suggests. Okay, this is what it suggests. It says, okay, I agree, I would simplify the design by making all persistent entities plain TypeScript types. Yeah, this is the way we work. Now it wants to types for entity, record, account, category, contractor, recurrence. It updates the doc, and then it goes and provides all the files. Let's go check it. Account, category, contractor, recurrence. Okay, one recommendation: record should be renamed. Okay, well, rename record to transaction. Okay, so I have created all those files, transaction, recurrence, contractor, category, account, recurrence. Interesting. Why do we need recurrence? Okay, so it was a mistake. We don't need a recurrence. I removed the recurrence. Let's delete it. Yes. Provide code for updated data schema markdown. Good. Just copy this and let's close everything and update this file. Good. Let's see what's changed. Data schema. Entity types. Good. Transaction, account, category, contractor. Relationship, transaction belongs to one account, belongs to one category, optionally belongs to one contractor, may reference multiple attachments. That's true. Let's see what the transaction type is. Direction, in, out, amount, number, account ID, category ID, contractor ID. Category ID is also optional. Contractor ID optional. Description, date, time, attachments, IDs. Good. Is actual. Recurrence ID. We don't use recurrence at the moment. Contractor name, description. Category name, description. Account name, description, currency, current balance. Good. Everything looks good. What is entity? Entity. Do we have entity type? Entity type. What is entity type? Okay, then entity. Okay, good. Then we need to add entity, new file, entity. Yes. Schema version ID created at updated at is deleted. Okay, do we need client ID updated by? Okay, we don't need it. For synchronization, yes, but for entities, no. Okay, agreed. Good. So this thing is also finished. We have finalized data schema. Okay, let's clean up our design. Do we need to update design MD? Everything about data schema must be in data schema MD. And this is the design markdown. Data model section. Yes, we remove a data model. Account data model. Identifier strategy. identifier strategy, remove data model, remove shorten migration strategy. Okay, migration will be addressed later. Simplify chunk metadata. Update client structure. Client structure. Okay, we need to update client structure. Client structure will be types, data models. Okay, core data models. We remove data models from here. Renaming references. There are still few references to records. Record transaction management. Okay. Avoid making expense records. Good. Results. Okay. So we will go through design markdown later. Maybe I'll do that between the episodes. For now, looks good. And I think, oh, wait a second. Transaction entity doesn't find entity. Why? It should actually. Transaction. Really? Yeah. Okay. Was a glitch. Good. So we just commit, update, add data schema and types. Update data schema and add types. Let's check again what changed. Entity, transaction, data schema. Looks good. Right. Let's push the changes. Let's close the tabs. Okay, the next is the storage format. Let's continue with the storage format. Let's open a new chat. Let's finalize storage format. Current docs. We need manifest, we need storage contract, we need design storage contract, we need sync. What else do we need? I think that's all. Oh, we also need manifest and concat those files. Content. Let's finalize storage format. What do we actually need? We need envelope, encrypted object. I actually need all this. We actually need this encrypted object, envelope, object naming, obfuscation, storage, layout. Yeah. Most of it is already done, but let's just finalize maybe the envelope. Maybe we need the envelope. Do we need a type for the envelope? For example, client types, data or storage, storage chunk. etc. Let's see what it says. Yes, I think we can finalize now. Alright, so this is what it says. It says that, yeah, we can finalize now, and it suggests to use one encrypted object envelope for everything. It says we need to keep the version, the algorithm, the encoding, payload. Yeah, that's basically this is the actual object. Or if we later support key rotation. What is key rotation? We use versions in sync process. Do you mean this? And we can also give the synchronization. Okay, what else? We don't need encryption, encoding and encryption. I'll go. This will be the same throughout the app. Okay, so object naming is good. Stable random object naming can be the same throughout the app. Let's say AZ098 length. Okay, then okay, so we have agreed on this, and it also suggests that all the objects will be kept under the object. Okay, I agree with this. I like this approach. Everything is in here. I agree, but we maybe need sharding for attachments. Can be thousands. Good. Exam manifest. Okay. Good. Chunks. Good. Chunks will be referenced in manifest. Attachments will be referenced in transaction records. What else? Storage layout. Okay, storage layout is good. Storage layout is good. Manifest is now complete. Attachments. Storage object type. Object type. Good. It is referenced in manifest. Final directory structure. Types. We still need the storage types. For example, accounts storage will be envelope and accounts as array of accounts. What else? Changes I'd make to the docs. Remove the reference, chunk, statistics, attachments. Okay, we'll do that. Replace the object names. Should be obfuscated. Okay, stable. Good. Move the encrypted envelope definition out of the do's and define it as common encrypted object. Alright. Remove discussion of an attachment map. Okay. Update design MD. Keep sync MD largely as is. Good. Now let's go and check what it says. So here's what ChatGPT says. Okay, key rotation, it says no, it's not related. Okay, so key rotation not needed. Version is enough for sync. Next, encryption algorithm. Good. Remove, no needed. Object names, I like fixing this now. Good. Storage layout, it suggests two first letters of the name. Actually, this is not good. Sharding, the first letter is enough. Gives 72 directories, enough for one user. Two letters will contain one file each. One, maybe two files each. What's next? Storage types. Storage types. Provide all storage types under client types storage. Good. Chunk storage. Yes, good. One thing. Okay. Good. I think we're very close to the finalization. All three decisions. Key rotation. Good. Sharding. Using the first is good balance. With 62 character alphabet, that's 62 more than enough for one. Good. Shard is simply yeah, no additional metadata is required. Storage types, I'd organize them like this: encrypted object, account storage. Okay, I have created all those files: account storage, attachment storage, category storage, chunk storage, contractor storage, encrypted object. Encrypted object will be used, not clear where it will be used. Where is encrypted object used? Drop statistics for now. And chunk metadata is missing. Chunk metadata is missing. Okay, ChatGPT thinks that we can simplify even further. Okay, encrypted object is used outside of these types. That's clear. And it also says that storage types will be enough without statistics. Good. Chunk metadata, it says it should be a separate type and it's not provided. Okay, I think that so it suggests that we need months created at. Okay, so let's talk further about this. Month is mapped in manifest. Really? Manifest. Schema version created at chunks month. Okay. Manifest. We also need schema version created at updated by at for all reference data files as well. What else do we have here? Reference storage types. Okay, good. Okay, here's what it says. It says that chunk about well, first of all, it says that it agrees, of course. Chunk metadata is already in manifest. That's good. There's no need to duplicate. Okay, so chunk metadata, good. It will have only schema version created at updated at and updated by. Then chunk storage will be just metadata plus records. Reference metadata same will be done to the every storage object. Okay, now manifest is the only exception. Good. Let's refactor the types. Provide all the types code. It will be client types storage, client types data. Provide all the types code for all storage types. They must import types from data and use the same metadata for all chunks and reference. Good. And while it's replying, let's move all the data types to the directory data. We move manifest to storage. Okay. Storage metadata. Create this one. Storage metadata. Okay. Account storage. Update this one. Okay, I have created all those files. Created and updated account storage, attachment storage, category storage, chunk storage, contractor storage, encrypted object. Good. Manifest storage metadata. I moved all the data types to directory data. I moved manifest to the storage. And that concludes our storage definition. The next step, well, let's first close all those tabs. The next step will be the chunk format. I think that most of it is already fixed, but we'll just review it. And let's commit all this. Update storage format. Add storage types. push. Okay, I think that we have already defined chunk format, chunk metadata, self-describing chunks. Self-describing chunks, what does it mean? Self-describing chunks. So we have the months, we have transaction, we have chunk storage will be the which is just the array of transactions, storage metadata. I think that everything is covered here, so we can safely go to the next step, which is encryption. And for that, let's start a new chat. Let's define encryption strategy. Current docs. Encryption. We also need manifest, and we also need the design. Copy this, concat, copy. Let's first clean this up. Encryption, related documents, clean this up. What else? Purpose, not needed. Security assumptions, encryption scope, key hierarchy, key derivation, object encryption, object envelope, randomness, object authentication, compression, passphrase, key rotation, recovery, versioning, migration, open discussions. Okay, let's keep it for now. Encryption, design, manifest, copy, concat, copy, concatenated, and all right. So here's what ChatGPT suggests. Recommended cryptography: encryption algorithm AES 256 GCM, key length 256 bits, nonce 96 bits, randomly generated for every object, authentication tag 128 128 bits, provided by GCM reasons, native web crypto support, fast authenticated encryption, no extra HMAC required, key derivation, use Argon 2ID if available, fallback PBKDF2 HMAC SHA 256. Since browsers don't yet expose Argon 2 through web crypto, there are two reasonable options. Option A, recommended, bundle a WebAssembly Argon 2 implementation. Okay, let's key derivation, simple option for MVP with future Argon 2ID extension. Let's keep it simple for now. Example algorithm key hierarchy. Key hierarchy. Slightly expanded passphrase, KDF, master key, hierarchy. Okay, if that's simple enough for object encryption, every object is encrypted independently. Good. Okay. Encryption envelope. Is this not encrypted. I avoid exposing anything on S3. Anything unencrypted. Can we use same encryption parameters for everything instead of envelope, using the envelope? Associated authenticating data. One thing missing from the current design is AAD. Instead of authenticating only the ciphertext, authenticate object identity. Really need it for the MVP? I don't know. Randomness, okay, no problem. Compression, yes, we need it, but maybe implement later, not MVP. Manifest itself, yes. Manifest, yes, encrypted, just like anything else. Attachments, passphrase storage. Passphrase. Enter on setup startup with optional don't ask again. Versioning, encryption versioning, where to store the versions. Good. All right, so this is what ChatGPT answers. Key derivation. Okay, well, first of all, it says that we can simplify the MVP quite a bit. So key derivation, use this simple solution for now. Store the KDF parameters in a separate local configuration or bootstrap object. Okay, let's add settings JSON, client settings JSON with encryption parameters, which will be used across all clients. Same code for all clients. Encoding migration will need encoding everything stored. Good. Key hierarchy, trivial. Okay, let's keep it like now. And encryption envelope. Okay, no encryption envelope. Good. Different encryption parameters. Okay, again it agrees. AD, no AD for now. Compression, no compression for now, but keep the design open for it. Passphrase, agree. Versioning, encryption versioning. Encryption versioning is stored here as well, maybe. Schema version, this does not belong. Okay, schema version outside of the scope. Bootstrap metadata, bootstrap metadata here as well, maybe. Good. Be very, very brief. All right, so it agrees on everything. Now let's finalize this step. Finalize. Create client settings JSON and client types settings. The settings type. Update and make minimal encryption empty. All right, I have updated the files. I have updated the encryption spec. I added the type for settings and I added the settings JSON. We will keep all the parameters for now as they are, and also let's update the roadmap. Update the roadmap. Encryption, key derivation, and compression. And provide complete updated code for this document. Copy and update. Let's see what changed. Roadmap, key derivation, scope. Okay, excluded, compression, phase 3, compression, key derivation, MVP. No, actually, key derivation argo to ID. Okay, phase 2 MVP. PBKDF2 and argon to ID will be in phase 3. Iteration 1 compression, and yeah, so that will be all for encryption stage. Let's commit everything, update specs, and add types and settings JSON. Good. Let's close all the tabs. Let's sync. All right, let's continue with the next step. Next step is migration. Let's create, well, first of all, let's look into this document, purpose remove this. Design principles, okay, let's keep it. Version types, schema version, storage version, encryption version. Let's remove all this. Let's keep it for now. Migration types to independent migration, local migration, IndexedDB database, remote migration, good. Migration rules, every migration must have a unique version number, good. Direct migrations are not required, is never example. Oh yeah. Object migration, every storage object is migrated independently, good. Read version, migrate, yes. Objects that already match the current are not migrated. Local database migration. So on schema version, when the application starts, read local version, apply required migrations, store new versions, good. Remote storage migration, remote storage individually, migration doesn't require migrating the entire storage at once. Objects are migrated when they are downloaded or updated. This allows gradual upgrades across devices. Okay, we will need a log. Okay, let's create a new chat. Let's design migration logs, migration version, where is migration version stored, manifest maybe. What else do we need? Migration failure, migration fails, preserves the original object, yes. Abort the current operation, report the error. The application should remain in recoverable state, that's true. Migration testing, every migration requires automated tests. Tests should verify forward migration. Oh, by the way, we need to add tests here. Introduce tests early. Yeah, we can do that after client setup. Maybe actually this will be introduce tests here early. Define test strategy, automated tests, user testing scripts, good. Migration, oh by the way, did we clean up the design? Okay, design, migration. So then we need this, we need settings, we need data, we need storage, we need manifest, right. That will be good. Do we need sync? Do we need storage? Yeah, let's add sync and storage too. Data schema, no, we don't need data schema. Okay, copy all this. Let's see if there's enough space in the chat. Current documentation. Yeah, there's enough space. Run. Alright, now let's see what ChatGPT suggests about the migration. Okay, so it says that it deserves their own protocol rather than being treated as just another thing. That's trivial. There are a few things missing from the current design. Who decides a migration is required? Who decides a migration is required? Let's answer them one by one. Who designs the client, either client, either client when it sees that migration version version in manifest and settings are different. Next, how to prevent two clients migration lock. Where migration state is stored. Manifest. How migrations interact with synchronization. No interaction. What happens if migration is interrupted? Migration should be revertible. Revertible when interrupted. Another considerations, client with lower migration version should crash or should exit, okay, gracefully. Operations. What else? Migration version from schema version, yeah. Manifest. Migration version plus settings. Migration version. Migrations are mini programs which do all the migrations. Migration flows, not standardized. Stored in client migrations 1, 2, etc. What else do we need to cover? Migration version belongs in the manifest. True. Introduce migration state. Good. Manifest migration state idle or running. Migration lock, oh maybe settings, migration, maybe like this, migration version, migration state, good. Migration lock, migration lock manifest, migration lock, good. Migration lock lifetime plus lifetime plus revert plus revert logic. Good. Recovering from crashes forever. Okay, another client might steal the migration, like a list, migration flow, and plus retry. Object migration. Good. migration types. Okay, already covered. Storage migration, sync interaction. Sync interaction. Sync is blocked while migrating, of course. Proposed manifest additions, good. Migration, manifest version, yeah. Manifest version, rename to manifest version. Good. Be very brief. Okay, I would keep it simple. Migration design, manifest migration. Let's add this to manifest. Manifest version, updated just version. Also rename. Login requires state running. Future failure recovery. Migration log has a timeout. Another client may take over. Migrations must be reversible, idempotent, so it interrupted migrations can safely retry. Client compatibility. Older client, good. Newer client performs the migration. Okay, exits gracefully. Older client. No start. Shows error. Client must be updated. Good. Migration mini programs, not scheme example. Yeah, IndexedDB, each migration is possible. Good. Update types. Do we need to update settings? Types for my settings for migration version. Okay, let's update the settings. Where do we have settings? Here. Encryption version, migration version updated. Then I start uploading it simply. Older client, good. Update the doc. Provide full code. Copy and paste. You can see what's changed. Design, where it is. Design versions. Okay. Architecture, identity, record, account, architecture, technology stack, infrastructure, security mode, identity, record, account, recurrency, local database, chunk metadata, local statistics, attachments, client structure, testing strategy. Okay, let's add this here. Version types, and we remove it from versioning. Storage version not needed. Migration version, yeah, here. Good. Encryption version, remove. So encryption version, encryption. Good. Migrations. What else do we need? Migration types, okay, keep it. Storage migration. migration program, good. Migration rules, okay. Direct migrations are never implemented, is not allowed. Good. Client compatibility, okay, that's good. Migration failure, okay, looks good, looks good. Update migration specs and types. Let's close all those tabs, we will not need them. Let's push the committed changes. And this will be all for this episode. In the next episode we will continue with client setup. Maybe we will go further and check the iOS PWA feasibility, and maybe we will also touch the tests within this step of the client setup. Okay, thank you very much for watching this. I hope that it wasn't too complicated. Leave your comments below, and see you in the next episode.